Hello, this is an instructional math video for Math 143. My name is Tyler Beamer at Haywood Community College. The purpose of this video is to show how to find savings plans, balances at the end of a specified period of time, making regular payments using Excel, and then also to find payment needed in a savings plan with a fixed interest rate for a specified period of time in order to achieve a certain balance, also on Excel. So we're going to be working off of the Chapter 4 Section C notes, and as you can see here, we have our savings plan formula, which is the formula that Excel is using to do the computation, and I have also given detailed work as to how to compute or how to find these answers using the savings plan formula, computing this by hand with a calculator. Okay, we're going to use Excel, and then hopefully our answers match up. Okay, so I'm going to work off of these examples. So example 1, assume monthly deposits and monthly compounding. Find the savings plan balance after 5 years with an APR of 2.5% and monthly payments of $100. So we're making fixed payments for a specified period of time at a fixed interest rate. What's the balance at the end of the period? That's what we're trying to figure out. So if we want to use Excel to help us, open Excel. Okay, and the function bar or formula bar, we'll start with hitting an equal sign, and then we want FV for future values, so we can type FV and it'll pop up here. We can double click it, and the Excel function will put itself in the formula bar. Excel is very user friendly because it gives us exactly what we need in order for this function to work. First thing is the rate, which is the monthly rate. Therefore, we need to take the APR, convert it to a decimal, so 2.5% as a decimal, 0.025, and then divide that by 12 to convert that into a monthly interest rate. Next is NPER, and that is basically how many deposits you make into the account. So to figure that out, I take the specified period of time, so 5 years, multiply that, and I can use the star to multiply, by 12 since I'm making monthly payments. So 12 times 5, so essentially I make 60 payments into this account in the specified period of time. And notice that, even for the rate and the NPER, I'm just putting in the actual computation. I'm not actually doing the computation, and Excel will do that for me. And that keeps us from having any rounding error. When I divide these, I may get a decimal, and if I type that in as a decimal, then I'll have some rounding error. If I type it in like this, that'll eliminate some of that. Okay. Next is payment. So how much I put in into the account each time. So I put in $100 into the account each time. I'm actually going to put that in as a negative. So negative 100. Okay. The next two is PV, so present value. So if there were present value in the account, I could specify that. In this case, there is nothing in the account, so the present value is 0. So I'm just going to leave that blank because Excel will default to 0. And then type, which is also in a bracket, is when I am depositing it. Am I depositing it at the beginning or the end of each period? And so in this case, I'm also going to leave that blank, and that'll default to 0, which means I am making this deposit at the end of each month. Okay, so I'm just going to leave those two blank. If they're in brackets, they're optional, and Excel has a default, and we'll just use that default. So in the parentheses, enter, and I get $6,384.05, and notice that's the same amount that I get by hand with my calculator. Okay, obviously Excel is much quicker and easier if we know how to use it. Example 2, same idea here. At an age of 25, you set up an IRA with an APR of 5%. At the end of each month, you deposit $75 in the account. How much will the IRA contain when you retire at age 65? Compare the amount of the total deposits made over the time period. So I can also use future values here for this one. Equals FV. Okay. Once again, I want the monthly interest rate, so 5% divided by 12. The NPER in this case is going to be 12 times 40, since the person invested for 40 years and they put in money each month. So 12 times 40, and then the payment was $75. I'm going to leave those other two fields blank. So $114,451.51, and that matches what we have here. Okay. So the fixed value, or future value function in Excel is really helpful to determine the balance of an account after a specified period of time making fixed payments. And the assumption here is that the amount of the payment for each month doesn't change, nor does the interest rate. Okay. Alright, example 3 is a little bit different. In this case, you're actually trying to figure out how much money to put into the account in order to save a specific dollar amount in a specific period of time. So your goal is to create a college fund for your child. Suppose you find a fund that offers an APR of 5%. How much should you deposit monthly to accumulate $85,000 in 15 years? So you can see that we're not finding the final amount, we're finding a payment. So, if we're planning ahead, how much should I put into this account? So we can still use Excel. We're not going to use the future value, we're going to actually use the payment. So PMT, and that Excel function comes up. And then it also tells me what I would need for that. So the rate, once again, is going to be a monthly rate. So 5% divided by 12. NPER, once again, is the number of payments that I'm going to make. So I'm going to make monthly payments for 15 years. So 12 times 15. PV, present value. Okay, so how much money's in the account right now? So nothing. Okay, so we're starting this account from scratch, so I'm going to put a 0 there, and that 0 is important. FV is future value, so what do I want the account to end up with at the end of the specified period of time? I want that to be $85,000. And I would not put a comma in for the $85,000 because Excel will think that is changing to a different field. So I would not put a comma there for $85,000, just leave it without a comma. And then finally is the type 0 or 1. 0 is it making this deposit at the end of the monthly period or at the beginning. So we'll default to 0 there, which is what Excel does if you just leave that field blank. So hit enter. Okay. And we get $318.01. So if we compare our answer, same answer. Okay, so you can see how we're doing this by hand here using the formula. We're solving for PMT, and we get that same answer. Obviously, Excel does it much quicker than we could with the calculator. So these are two very valuable functions in Excel, which I think will help you in your homework and quizzes. So I hope you use those, and I hope you find this video useful. Thank you, and have a great day.